Now, some basic operations. Now, believe it or not, A is actually are actually complex numbers. It's just that we have the square root of negative 49, we have the square root of negative 4 kind of replacing the imaginary parts. Because if I'm looking at the real number system, I wouldn't be able to do anything at all with that number the way it's that expression the way it's written. Because in the real number system, I can't do the square root of negative 49, the square root of negative 4. But I can look at the square root of negative 49 as the square root of 49 times the square root of negative 1, which becomes 7i. I can look at the square root of negative 4 as the square root of 4 times the square root of negative 1, which becomes 2i. So what I end up having here for the complex numbers, I have 4 minus 7i plus 3 plus 2i. As far as how you carry through the addition of complex numbers, all I'm going to do is add the real parts and add the imaginary parts. Kind of behaves a lot like how we added vectors. And some of the procedures we've done for vectors, we've done for polar coordinates, and then now we're doing for these complex numbers seem very similar, which is why some students confuse them slightly. Be very careful that you don't confuse, how we add complex numbers together with doing something with complex numbers that we did with vectors, which may not be the same thing. But as far as doing that, adding the 4 and 3, I get 7. Adding negative 7i and 2i, I get negative minus 5i. So the final answer is 7 minus 5i. In complex numbers, that is a single number. Even though it has two terms in it, it's a single number. And that's what we're looking for.